morning, everybody. My name is Mirela Gutica, and I am teaching and conducting research in the CST department. And I'm here with my students, Stephanie Kosacescu, Wilson Hu, Josh Abbey, and Jake Choi. And I am presenting my research project, Building Advanced Technologies for Improving Girls' and Women's Participation in STEM. So the overview of the presentation, I'll talk about the research question, the study design, recruitment and participants, results. Then we'll talk a little bit about the HoloLens project, future work, and then questions and answers. So the research question that was proposed for this study is to find strategies and instructional models and technological tools, for example, educational games, that can be used to motivate girls and women to choose and to stay in STEM or computer science education and careers. So this study is sponsored by BCIT, generously sponsored by BCIT, and I want to give you an overview of the study so far. So the purpose is to improve diversity and inclusion. In our program in CST, we have a very low number of female students. We have the number is lower than the number in universities or other institutions who are in the local area. The timeline of this study is 2016-2019, so we had another presentation last year. And so there are two directions. One direction is to explore the reasons for this gender imbalance, and to look at gender differences. And the second one is to design the strategies and technological tools. So the study has a methodology based on mixed methods. There was a qualitative study that started in 2016. We collected the data. So qualitative studies are very time-consuming. They are still, analyzing, but very, very close to the end. Then there is a quantitative study to generalize the results of the qualitative study, not started yet. And for intervention, the intervention didn't start, but we started to build some technological tools. So the research team, I want to mention to you that I had many students. As you can see, there are 8 students enumerated here. So several students who participated in this study. So currently, this is my team. The other students graduated. Related to the qualitative study, we conducted a literature review, and we look at literature related to women and girls in STEM and computer science. We also look at theories of motivation, and we look at attainment theories, more precisely to the expectancy value theory of motivation of Eccles. According to this theory, somebody's confidence to pursue and to persist in an activity, an educational activity, is based on 4 factors or 4 values: attainment, which is self-image, intrinsic value, which is enjoyment, utility, and cost. So we created an interview guide. The interview guide was based on theory. And we conducted semi-structured interviews with our participants. The interviews were conducted by 2 research assistants. The interview participants, we tried to choose a variety of participants from our institution, from our program, and we looked at current students who at that time just graduated. We also invited students who were not successful in the program, who decided to leave the program. And in terms of gender distribution, we had male students, female students, and we had 2 transgender female students participating in this study. And now I'll give the microphone to Steph, who will continue the presentation.
Good morning. Right, in terms of results, as Mirela has mentioned, this was a qualitative study, so we didn't do like a quantitative type of statistical analysis on the results. We're looking more as each individual student as a case study or a story. That being said, we're also looking for, of course, patterns amongst all of these students to try to gain some insight or results or similarities or even differences based on what we've heard. So what we were looking for in terms of patterns were the 4 things that we were looking for in our matrix that we defined when we made our interview guide. So attainment values, intrinsic, cost, and utility. Interestingly, what we found when we did our literature review was that not many people were looking at cost or utility, so that's something a little bit new. But we did read a bit about attainment and intrinsic values. In terms of attainment, we saw quite strong gender differences, which was funny because in intrinsic values, we didn't actually see many gender differences, which you would expect to either see them or not see them at all. So attainment would be defined as sort of self-image, what you see as important or valuable, whereas intrinsic would be what you enjoy, so what you're passionate about, what you have fun doing. So yeah, in attainment values, we did see the gender differences in terms of role models, stereotypes, definitions of success. So for example, when we asked men about what they would define as successful, they generally mentioned, financial stability, job security, success in that role, whereas women would list those things, but also describe, having a family and also being able to support that family. In terms of intrinsic, like I said, we saw generally the same thing across all of the genders. So you'd think that since there are these gender differences and these gender imbalances in STEM fields, maybe boys grew up differently or they play different things, but actually we found that boys and girls play the same type of games, such as Lego or building blocks or video games, and also that boys and girls or women and men reported problem solving in sort of equal amounts. In terms of cost, of course, we know that this program is pretty rough, so it was generally reported by all of the participants, stress, wellness, especially healthy food options on campus, that was a big thing. But when it came to struggles, we generally heard that from female students. So this program was so difficult, I barely survived it. I didn't sleep, I didn't eat, things like that. Males didn't really report that. And then when it came to harassment, that was only female students that reported bullying, maybe some verbal comments or being uncomfortable in class, sometimes being followed by students, stuff like that. And then as for utility, as I said, generally the same, but we did hear from female students that, I want to be able to provide for my family, I want to have a family, things like that. And then another thing we looked at was confidence. So self-confidence, where do you find that sort of confidence to pursue this program in the first place? How do you actually persist in that program, even though it's tough and challenging and maybe discouraging at times? A big thing that we found in terms of increasing confidence was role models, and then studying at BCIT, support, and teamwork. So role models, one interesting thing was that female students really reported a strong influence from their fathers. And you'd think, their mothers or their friends, but actually fathers were a very, very strong influence. But when we came to male participants, actually what we found was that they spoke more about their high school teachers and their instructors here at BCIT who really influenced them. So say a coding class that they took in grade 11 or a specific lab instructor. And then another thing we found was that when it came to actually choosing to come to BCIT in the first place, the influence there was friends or family members or people who they personally knew that had come to BCIT and had told them, hey, I did really well and I got a job, or hey, this program is really awesome and you should consider it, rather than finding the program online or searching or from career fairs, things like that. One other thing that improved confidence was actually studying at BCIT. So being able to say, yes, I finished that project, that industry-sponsored student projects, which you guys might know we have, and it was really hard, but I did it, and so that was a big confidence booster. Support, of course, that could be from family, but also from instructors. A big thing was positive feedback. So from those lab instructors that you have, really getting a lot of feedback from them. And then teamwork was really interesting in that we expected, the stereotype is that computer science students don't like to work collaboratively, they prefer to work alone. But actually all of our students, except for one participant, reported that they preferred working collaboratively.
Thank you. Unsurprisingly or surprisingly, all participants were actually coded as having stereotypes. Generally, the participants claimed that they did not hold stereotype beliefs, but were revealed to actually do hold some stereotype beliefs when asked about them indirectly. Generally, female identifying students have been subjected to stereotypes, whether it be at BCIT or in the workplace. And they've also been suggested to traditionally female career roles. Notable examples are stewardess, secretary, and nurse. And surprisingly, I think the most surprising result actually would be that some female participants hold strong negative gender stereotypes themselves, such as the expectation that they will go on to have a family and be the one that cares for the family while their husband makes the money, I guess. With regards to our study, we've come up with some recommendations for BCIT. We'd like the school to discuss gender diversity issues early on in the program, so kind of tackle the issue head on before it becomes a problem for female students later in the program. Find better ways to identify at-risk students, so students who are struggling significantly and are at risk of dropping out. Provide curriculum changes aimed to foster collaboration early on. Provide more support for gender diversity and transgender students, and improving student wellness, especially because students need healthy food to succeed in the program, and Timmy's isn't doing that very well most of the time. And with regards to early intervention, expose students in middle and high school to technology and kind of foster the interest early on. And moving on, I'll have Josh talk about our early intervention.
All right. So in addition to the qualitative research, we had a sort of an intervention tool that we were working on. This was a HoloLens project. For those who are unaware, it's an augmented reality headset, which basically allows you to interact with virtual objects in the real world environment. And this project was called CodeBlock. So the project goals with this, essentially we set out to make an intervention tool, as I mentioned. And this was to sort of complement the research findings from the qualitative section. The idea behind using HoloLens was that it would increase the visualization as well as offer a novel medium, so it's a little bit more interesting than your sort of standard game, I guess, in that sense. And also, since it was completely developed by students, it would offer sort of inspiration to younger students of computer science to be like, hey, I can make that at some point. Also, so the primary demographic for this project is for middle or early high school students. It was found in the qualitative section that this was probably the pivotal point in education to get people interested in computer science and STEM. So this game actually took the format of a block coding game. And now to give a little context to that, just in case you aren't familiar, basically what this does is break coding down into discrete chunks, like literally blocks. And it allows for them to sort of simplify the concepts and get used to the idea of how certain words in coding interact with each other. In addition, there's sort of a gamified aspect of this, so it's not just coding to see various lines doing certain things. It's there's a game environment, and you need to navigate it somehow by using the code, basically. So I prepared a little demo reel, just like 30 seconds.
This is Casey. Casey needs your help navigating these confusing levels. Grab blocks of code from the block factory and place them inside the block tower. Once you've made up your mind, have Casey navigate through the level based on your commands. Well, he will soon. Code Block, teaching youth to code by helping an adorable bear.
So, just as a sort of side note, as you can see, it's not completely done. There's code blocks and there's a tower to code in, but he doesn't move yet, so we're getting there. So, based on that, we have sort of an intervention tool as well as a qualitative research section. And so future work would mean working on the quantitative section to allow for generalizations of our findings, and also actually applying the intervention tool and other intervention methods to basically increase the exposure for younger women and girls in STEM. And that would be our presentation. Q&A. That's fine. 3 minutes. No questions? Awesome. No question?
So this was not a survey, this was a qualitative. So we had 21 participants. However, we decided to keep only 19 of them for various reasons. So in qualitative research, the quantity is not that important, but the quality. So there have been in-depth interviews. Probably the shortest one was a little bit more than 1 hour, and the longest was close to 3 hours. So we learn a lot from the participants. The idea was to explore and then to generalize. So the next stage is to run a survey with students from here and students from other institutions as well, to see if our findings actually can be generalized. One more question? Yeah. So I believe that one important aspect is early intervention, and this is why we are working towards some strategies to have how to say, meaningful way to introduce coding and coding concepts and computational thinking to students who are younger. And I was thinking that middle school, it's a good time. And of course, we should make sure that we understand our students and we improve the conditions in our institute such that female students feel more comfortable. So there have been some recommendations, and what, you know, for example, we already brought some awareness. We went to a SETREP meeting and we talked to the SETREPs and we told them, look, there is harassment happening and you have to pass this message to the students. So this is not acceptable, right? And also tell students where to find help, right? So there are several ways, and of course curriculum development, but we didn't go in that analysis yet. But curriculum can be changed such that it is more interesting for female students. Yeah, so there are many ways we can improve. Yeah. Yes, of course. You know, I look at literature review, but to tell you something unique about our, well, I don't recall issues of harassment. However, I recall issues of stereotypes. So many, you know, research papers talk about stereotypes. They also talk about differences between genders, right? I didn't see a study that has transgenders in it, so this is also unique for our study. And with respect to role models, there have been also studies talking about role models. There have been studies about collaboration, and actually studies about collaboration say that women prefer to collaborate, men prefer to compete, and we didn't really find this. We found quite competitive women, you know, in our sample size, in our participants. Eccles' theory of motivation, the expectancy value theory of motivation by Eccles, have been used a lot in middle school and high school. It had been used only once in post-secondary school. So again, this study is unique because it's using a theory that generally is not used, and actually there is not that much interest to look at attainment of, you know, in post-secondary because people are already there, right? So you prefer to look at attainment earlier. So there are some unique aspects of this study, but yes, we did a very, very serious literature review to prepare ourselves for this study. You're welcome.
Thank you, Mirela and the student team for this.